in 5, 4, 3, 2.
Hey, what up world? Welcome to IChem. It's the members of your nation, Carly
and Sam. Today we're going to do something a little different.
I want to talk to all of you about a very important issue, the thickest crisis in America, acid rain!
Now, what exactly is acid rain, you might be asking?
According to EPA.gov, acid rain is caused when compounds like sulfur dioxide and nitrogen oxides are released into the air. Both can dissolve easily in water and can be carried far by the wind. Therefore, they can travel far distances. As a result of these two properties, they end up mixing with rain, snow, sleet, and fog.
Also, according to EPA.com, y'all bozos are the main cause of this trash. Thanks a lot!
Sadly, Sam is right. As stated by NationalGeographic.com, sulfur dioxide and nitrogen oxide are released into the atmosphere when fossil fuels are burned.
Because Miss Hallaby makes us do all those sciencey things, I'm going to explain a little bit more about what this is. Now, let's explain the natural acidity and in the rainwater and some chemical formulas. As chemistry.wustl.edu, carbonic acid, which is formed when carbon dioxide reacts with water and is the main cause of natural acidity in rainwater, decomposes to form hydrogen ion and a hydrogen carbonate ion.
Since carbonic acid can form a hydrogen ion, this molecule is an acid, which lowers the pH of a solution, according to chemistry.wustl.edu.
All right, my turn. I gotta say some stuff so I can get enough credit. According to chemistry.wustl.edu, again, nitric acid also is a big contributor to natural acidity of rainwater. It is formed due to the reaction of nitrogen and oxygen during lightning storms. Nitrogen and oxygen come together to form nitric oxide, which is then oxidized to form nitrogen dioxide. This then reacts with water to form nitric acid.
Alright, we've covered natural acidity in rainwater, so let's get into the acidity that we humans cause. We cause much more acidity than natural acidity does. In fact, according to chemistry.wustl.edu, some parts of the U.S. have rainwater with a pH of 3.0 or lower.
Whoa, isn't that like 1,000 times more acidic than normal rainwater?
Yes, it is. Now shut up. In addition to natural sources of nitric acid contributing to rainwater, high-temperature air combustion, which can occur in things such as car engines and power plants, produces nitric oxide gas, which, as you can see in the equations we showed you, forms nitric acid.
This gas that happens naturally, with levels tolerable to the environment, ends up hurting the environment to the increased activity that humans give it.
We gotta stop. Anyways, another contributor of acid rain is sulfuric acid. It is produced almost entirely by human activity, fossil fuels in particular. When fossil fuels are burned, the sulfur in them reacts with the oxygen in the air, producing sulfur dioxide, which reacts with water to produce sulfuric acid.
So, you may be wondering, why is acid rain so bad?
Of course, you ignorant people don't know.
That's why we're going to tell you. So get ready, members of my nations, because we're going to educate you on the negative effects of acid rain.
According to EPA.gov, as acid rain moves through the soil, it can leach aluminum from soil, clay particles, and go into streams and lakes. If there's more acid, there will be more aluminum, which is bad for the environment. The acidic water makes it more difficult and dangerous for fish to hatch their eggs, in which a pH of 5 is too acidic for them. It also applies to many other species who are especially sensitive to such conditions.
Some other things that are hurt in the environment due to acid rain are trees and the plants around them. The acid rain steals nutrients and minerals from the soil that the trees need to grow. Also, at higher elevations, acidic fog hovers around the trees, stripping them of their daily needs, leaving them with brown and dead leaves.
Aw, poor trees and fishies. How can we help them?
Well, one option scientists has found is reducing the amount of sulfur dioxide released from coal-burning power plants. One option is to use coal that contains less sulfur, or washing the coal to remove some of the sulfur. This includes installing scrubbers in power plants.
But aren't those super expensive?
Yes, I was getting to that. According to the power.eng.com, U.S. Coal-fired plants invested more than $30 billion on scrubbers in 4 years, making it a very costly option.
Instead, we'd like to propose another option. We should decrease the use of cars, which would decrease fossil fuel usage. You could ride your bike, which is healthier for you and the environment. But what about the people that have to use their cars? Well, we can carpool together, which would decrease the use of cars and then decrease the use of fossil fuels. So thank you for listening. And remember, Chem stars of our nation, there's no Earth unless you save one.
And remember to check out IChem.com.